Hello everyone. In this lecture we're going to talk about continuous, binary, and count outcomes. The reason we cover this topic is because power and sample size software works best for continuous outcomes with a normal distribution. However, it does not work that well for binary or count outcomes. So we'll talk about how to recognize those things, and then you will know for which models you can do reasonable power analysis and for which one you will not be able to do a reasonable power analysis. We will define all three types of these outcomes. We will also make sure you know how to identify them so you are able to recognize them in your work. Finally, we'll talk about binary and count methods in software as they pertain to power and sample size analysis. Also note that you can see the term Poisson in the slides. This is another term to describe count. Let's start with continuous outcomes. These are variables that run along a number line, including fractions and decimals, which gives it a feature you see in this definition where it says a potentially infinite number of possible values. The example here asks, when do children first walk? You can see there are an infinite number of possible values for age and months. Another example could be exact height or weight, as these values would run along a continuum or a number line and could be any value. Binary outcomes, on the other hand, can only have two possible values. Binary outcomes are coded as dummy variables. I believe that we've talked about this with labeling, treatment, and control. In the example here, if participants graduated, we would give them the code of 1, and if they did not graduate, we would give them the code of 0. We call it a dummy variable because the values 1 and 0 do not actually mean anything numerically, but it makes it easy to analyze using these coded values rather than the words graduated and did not graduate. Yes and no questions are binary outcomes. There are only two possible values that the outcomes can be. Poisson or count outcomes are variables that increase by whole numbers and can be counted. Here the example looks at the number of car accidents that have occurred each year. We wait a year, we count all the car accidents that occurred, and we end up with a Poisson outcome. This differs from continuous outcomes because there cannot be 362.3 car accidents. Therefore, there is not the infinite number of possible values we can see with continuous outcomes. So why do we care about this? We want you to be able to recognize these different types of outcomes in your work so you can make decisions about which of the outcomes can give you accurate power and sample size analyses. Power and sample size software typically works great for normally distributed continuous outcomes. However, the software is not so good for binary outcomes and not so good for Poisson outcomes either. Glimpse, for example, the software we use in this course, does not deal with binary or count outcomes, only continuous. Let's do a quick review summary. Continuous variables run along a number line, including fractions and decimals, so there are potentially infinite number of possible values they can have. Binary outcomes have two possible values like yes or no questions or dummy-coded variables. Finally, Poisson outcomes are counts. They can increase by whole numbers as occurrences that are of research interest that happen. Remember, the software we use in this course, Glimpse, is only for continuous variables. For binary and Poisson data, power and sample size in general is limited. That's it for this lecture. Thanks for your time.